All right, welcome guys. Why don't you pull out your notes for yesterday? Actually, I want to take a look real quick and review what a GCF was. Some of the classes we didn't quite get there, so this will be the first time you're seeing it. Um, GCF, to pick up where we left off, is kind of the reverse of the distributive property. So let's go ahead and mark that down. If I can write here, reverse of the distributive property. And there we go. Where the distributive property, we take something that's in front of the parentheses and we multiply it to all the terms inside. So whatever is in front of it can be any expression, any term we want it to be. A polynomial, we'll see soon enough. We multiply it to whatever is inside the parentheses, to each term that's inside. So what we're going to do is we're going to do the reverse of that. We're going to find something common in all three of these, or however many terms are inside of our parentheses. We're going to find something common in each of these terms, and we're going to divide it back out. And that's going to be our GCF. So GCF stands for greatest common factor. What's common between all three terms, in this example, for number 6 anyway, is we're going to divide that back out. So let's go ahead and attempt to do that. The first question here, I kind of changed it from what your notes say. This one just wants us to find the GCF, and then we're going to factor by GCF. And I'll explain what factor is in a second here. So again, this is just a warm-up, just a little review from yesterday. So looking at this one, what you should do when you attack these GCFs, and this will become second nature for us, but we start by looking at what's common between the coefficients. So we got a coefficient of 4, we got a coefficient of 12, and a coefficient of 8. Really, it's a negative 8. And we don't need to pay attention to the negative unless sometimes it's in the first position here when it's in standard form, and this is. So looking at just the coefficients, we want to see the largest number that we can divide out of each of those. And 4, 12, and 8, the largest number we can divide out is 4. Okay. We're not actually going to divide it out right now because it just asks us to find the GCF. So we're just going to practice finding it. And then in the next one, we'll show what the results is after we divide out that common factor between all three terms. So we find a 4 between the coefficients, and that's just a regular division. So you're just looking at the numbers and divide out what the largest number is. It comes out evenly of all of them. When we look at the variables, though, it's a little bit different because our rules are different with this. With the numbers, we can just divide it out. But if you remember, if we take, and this goes back to our exponent rules, we take some variable and we divide it by the same variable, so common bases, if you remember correctly. And if we have something like this, x to the 4th divided by x to the 3rd, what we do, and if you remember exponent rules, is it says you take the numerator or you take the variable and you take its exponent and you subtract it from the one in the denominator. So what we find out is it's a subtraction between this, not an actual division. Where the number is a division, so we take 4 divided by 4, 12 divided by 4, and 8 divided by 4, and the result, again, common factor is 4, and we'll have the results of that in a second. But when we do the variables, you'll find that it's a subtraction. So sometimes students get mixed up with that because it's the division for the coefficient, but a subtraction for the variable. So just kind of remember that. Maybe we'll make a little note over here on the side and put that in our key points. When finding GCFs, we'll label it here. It's a division for coefficients, but a subtraction for exponents. And maybe I should have made a subtraction sign there just to keep it the same, but either way, you get the idea. So that's our little rule of thumb that we're going to keep here. And again, this will become second nature. You'll be able to do this quickly. So later on, once you see it and do it a few times, it becomes pretty common for you. So looking at this, we got our coefficients. We divided out of 4. We said that was common between all of them. And now when we look at the x's, since we're going to subtract a value of x out, we can really only subtract the smallest number that's available. So our degree is 3 here, but 2 here, but only a single degree of 1 here. So the most variables that we can subtract out of all 3 of these terms is going to be an x to the first, because we're limited by that one right there. So the GCF for that first polynomial here, right, 4x cubed plus 12x squared minus 8x to the first, the GCF for this is going to be 4x. That's the largest value that we could divide out of all 3 of those terms. And just to review again also, let's name this one. It's in standard form, highest degree on the left. So we can see here that our highest degree is a 3. So with a degree of 3, we would call that a cubic. And then we would name it by number of terms. And our number of terms actually is also 3, right? 1, 2, 3 terms. So our terms is 3, so we'd call it a trinomial. Again, just a little review. IAL, so trinomial. Let's take a look at B. We'll go a little quicker on this one because we don't want to spend too much time with this. But looking at B here, we've got 5v to the 5th power, and we've got 10v cubed. Again, look at the numbers. The largest number that we can divide out of both of these seems to be a 5. So we can take 5 and divide 5 by 5, and we can divide 10 by 5 evenly. Now we're going to look at the v's. Again, we're limited to the smallest degree of the same variable that we have there, and this is v cubed. So we can actually take a v cubed out of both of these. And again, we can take 3 out of here, leaving a v squared when we were done, and this would leave no v's because it would be v 3 minus 3, which would be 0, so it would be actually gone. But that is our GCF there. So now let's take it a step farther and look at our GCF in a form of factoring. Factoring means taking and breaking down a polynomial into smaller terms. Again, through division is the easiest way to think of it, and we're going to find different ways to do factoring, but this is the first way that you're going to learn to factor is through the GCF. This is our very first way, and this is what we should always check for first when we get to factoring in the next unit. We'll spend a lot of time with it. Even the next lesson, we'll talk a little bit about factoring again too. So let's again do what we did up here. We're going to check our coefficients, 3 and 18. We got to find a term common between those two, and that's pretty apparent. It's going to be 3. So we're going to take and write our GCF right here. So far it's 3. And then we're going to start a little box of parentheses here. We're up here, we just found the GCF between these two examples. This one, we're actually going to write what's left over inside a set of parentheses because we said it was a reverse distributive property. So when we're done, we should be able to distribute our GCF to 2 terms. Again, whatever's left over after we divide out our GCF, and it should make what we started with. So let's continue that process. We got our 3 because that's common between 3 and 18. Let's look at our variables. The first term here does have a t squared, but the second term does not, which means that there is not a common t variable that we can subtract out of both. So we can't take any t's out. So really our GCF for this one is just 3. So let's divide 3 out of both of these terms. 3 divided by 3 is 1, leaving just a t squared because we couldn't subtract out any t's. So that t squared is going to stay there. And now we're going to go ahead and there's a subtraction sign. We're not changing any signs. We didn't take a negative GCF out. And then 18 divided by 3 is 6. So that would be our GCF multiplied by the results of taking the GCF out. This is factored. This is a form of this polynomial being factored. We divided something out. We simplified it. That's really kind of what factoring is getting at. If we wanted to, we could go back and check our work and just multiply 3 to both terms. Because it falls under the distributive property, so we would multiply it to both terms inside. We should get the same thing that we started out with. So 3 times t squared is 3t squared, and 3 times negative 6 is negative 18. So we got what we started with, and that's kind of what our goal was here, is that when we GCF factor, then we should end up with our result when we multiply it back out. Let's do one more of those, and we're going to move on to the new notes today. All right, so let me change my pen back to red so you can see it. So looking at these 3 terms here, we've got a 4b cubed minus a 2b squared minus 6b. It is in standard form. We can name it real quick. It's a cubic trinomial. We didn't name this one. This one would be a quadratic binomial because there's 2 terms. Just to say them out loud to get you used to hearing them. So let's go back to this. Our coefficients is a 4, a 2, and a 6. 2 looks to be the only thing common between all 3 of those numbers, so we're going to take out a 2. That's going to go in front. That's the first part of our GCF. Now we're going to look at the variables. So I've got a b cubed, a b squared, and a b to the first power. Again, by the examples that we have, the minimum amount of b's that we can take out, or the maximum amount of b's I guess we can take out, is the lowest amount we have, which is b to the first. So our GCF is going to be 2b. Now we're going to divide all 3 of those terms, and we're going to write them inside these parentheses. Again, reverse distributive property, so it is a multiplication, not addition or subtraction between this, because we want to be able to multiply it back in. So 4 divided by 2 would be our first part. Is going to leave it 2. And then b cubed divided by b, again, a subtraction of the exponents. So 3 minus 1 is going to leave a b squared. So 4b cubed divided by 2b gives us 2b squared. Okay. Let's move on to the next one. Negative 2 divided by 2 is going to leave us a negative 1. And then b squared divided by b, again, a subtraction of the exponents, is going to leave us just 1b. We can write a 1 if we want, but we really don't need to. Looking at the next one, negative 6 divided by 2 is going to leave us a negative 3. And then our b to the first divided by b to the first, well, that's going to turn into b to the 0 or 1. So it really kind of is gone. It disappears. It turns into a multiplication of 1. We don't really see it. So this is the GCF, or the factored form by taking the GCF of this polynomial here. That would be our correct answer. Now we can check it by multiplying it back out, and we should see that we get the polynomial that we started with. So 2b times 2b squared, well, 2 times 2 is 4, and b times b cubed, again, that would be an addition. Multiplying of like bases means our exponents add, so we get b cubed. So far, so good. 2b, or 2 times negative 2, or negative 1, is a negative 2. And b times b, again, add exponents, is b squared. And 2 times a negative 3 is a negative 6. And there is no b's to multiply, so b stays the same. And if you look, we got the exact same thing we started with. So there's your review, or the first time you got to see GCF. Again, there's some additional videos on my PowerPoint. There were actually some really good videos with the GCF that takes you through this process, even a little bit more so. He'll actually break it up and show you a little bit more about the division. So there's some good videos there. Let's stop and take a moment and flip to our next section of notes. So go to notes 2 at this point. All right. Now, all right. So now you've flipped to your, I think I said notes 2 on there, and I really meant notes 3. Sorry about that, guys. I forgot we skipped that activity. So really, we're going to go to notes 3. So I'll give you another second, and I'll chit-chat while you guys are pulling up your correct notes there. So go to notes 3, which is multiplying binomials. And multiplying binomials is really similar to what we did yesterday. Really, yesterday, the GCF stuff. We did kind of get to a little bit of multiplication when we took a monomial, and I'll show you a quick example. Some term, right? Monomial term, those are kind of synonymous, meaning the same thing. So we took some term and we multiplied it by a couple other terms inside some parentheses. We did something like this, right? The distributive property is what we called it, and we multiplied it out like this. So what we did here was we took a monomial and we multiplied it by some other polynomial. So this would be multiplication by monomial, if you wanted to call it that. Now we're going to talk about a specific two polynomial multiplication. Again, we're going to say by binomials. Okay, binomials meaning two terms. And the fancy way to say this is multiplying binomials, but you know it and you've seen it before, called FOIL. And this should be something that you're familiar with. I'm not a big fan of the word FOIL. I don't like the acronym because it kind of takes the math out of it and gives you a process and you don't really understand what you're doing. I prefer to call it the distributive property because that's redundant. We do the distributive property quite frequently. It's common in a lot of different things, and it's something that's a little bit more consistent through all of your math. So FOIL if you like. I have no problem with you using FOIL. If you prefer FOIL, you're comfortable with FOIL, keep foiling. And so this will be very much a review for you. Distributive property is something that we've used throughout the year, and I like to consistently say. So you'll see me do this, and I'll use the arrows. But I'm also going to show you a new method called the box method, where, and you can see it right here. The box method is something that we're going to kind of work into when we get to factoring. There's multiple ways to factor is one of them, just like I'm showing you 3 different ways to multiply today. I'm going to show you by distributive property, by FOIL, by box method. When we factor, there's a bunch of different methods also. The box method, though, works for multiplication and factoring. So it's kind of nice. Gives you a little bit of a structure. It shows kind of the math through it, too, and it lets you show your work, which is also really nice for me to see. So what we're going to do is then show you a multiplication of 2 polynomials, specifically binomials. Here's the great part about the box method, where the distributive property will always work for any multiplication of polynomials. And what I mean by that is we're talking about 2 terms here by a 2 term. So here's 1 term times, or a 2-term binomial times another 2-term binomial. And the distributive property work if we added, I don't know, 6, 7, 8, 9, 10 more terms. It doesn't matter how many terms we have in there. It'll work for all of these polynomials that we're going to multiply by. Also, the box will always work. Okay, however many terms you have in your polynomial, again, we're multiplying binomials here, but if we add a trinomial times a trinomial, the box will still also work. The one thing that you'll find, though, is that FOIL will not always work. FOIL is very specific. It is really only for binomial multiplication. So a binomial times a binomial. That's the only time that it will work. So not always, it will, I don't know, not always isn't probably the best way to say that, but it will not always work. So that's the other thing about FOIL that I don't prefer about it. But let's take a look at these. The distributive property you're pretty good at. We've seen it, we've done it, so let's go ahead and do that. Again, all I do for the distributive property is I say, okay, here's a set of parentheses right here. This x plus 4 is in parentheses, and whatever's in front of it has to be multiplied to everything inside. Again, yesterday we saw a single term being multiplied to both terms, but now we've got a whole set of parentheses multiplying. All that means is both terms inside the first parentheses, this 2x and this 3, both have to be multiplied to both parts inside the second parentheses. So this is where the arrows come in handy. So I'm going to take and multiply 2x times x, and then I'm going to multiply 2x times 4. That's the first part. The second part of my distributive property then is I'm going to take 3 and also multiply it to x, and I'm going to multiply it to 4. When I'm all said and done, I'm going to combine any like terms, I'm going to put it in standard form, and then I'll have my product, my multiplication of those. So let's do that really quick. And I'm only going to do one of these examples just to keep this time short. So 2x times x is going to give me 2x squared. Remember when we multiply like bases that our exponents add up, so it's going to be a 1, right? Degree of 1, even though we don't see it, and another degree of 1, so this is going to be x squared. Okay, again, remember those rules, the properties I wrote on the board, they're still up there. You got to be good with those so that you don't make any of these mistakes. All right, let's continue on. So 2x times 4 is going to be, and again, they're both positive, so I'm going to add these. I need to make sure that I put an operation of addition or subtraction between these, because I'm doing the multiplication, and there's going to be an addition between these, because these are each new terms when we're done multiplying. So 2x times 4 is going to give me 8x. 2 times 4 is 8, and there's no x's to multiply, so that'll just stay 8x. Now I'm going to do the same process with the 3. 3 times the first term in the second parentheses, so 3 times x is going to give me 3x. Again, plus. The only time that you'd put a negative there is if one of these terms were negative. So if you look over at b, when you multiply by 7 here, you're going to get some negative terms to come out. Okay, and then 3 times 4 is going to give me 12. So right now, I'm pretty close to done. All I have to do is double check to make sure that there's any like terms that I got to put together, and I can see that there's a linear term and a linear term here, right? Linear meaning that it's got a degree of 1. So I've got 2 linear terms that I'm going to add together. This is a squared term. It doesn't have any other squared terms, and this is my constant. It also does not have any other terms to go together. So all I'm going to do is combine these middle terms, and then I have the highest degree on the left already. I have the lowest degree on the right. It'll already be in standard form, and I'll be done. So 2x squared, that's my highest degree. So this is a quadratic polynomial. And then 8 plus 3 should give me an 11, so plus 11x. And again, when we add like terms or monomials or whatever you'd like to call them right now, either way is fine. You're going to add, your exponents are not going to add. They'll stay the same. Just coefficients will add up. And then plus 12. Okay. So you can see where those rules that I gave you are pretty important, because we cross over the multiplication ones here where we add the exponents. Over here we're combining where we don't add the exponents, so you do need to make sure that you're pretty clear on those rules. Again, some of this is probably slow for some of you, some of it's probably the first time you remember it, so it's okay. We're all in little different spots, but we'll get to the same. So that's what that would look like when we multiply out by the distributive property, something that we're probably pretty common with. Let's jump down to the box method. It's very similar. I think, nope, I didn't use the same example, but it's very similar. What you'll do for the box method, and I think you guys have this in your notes already. If you don't have it, excuse me for a second. If you don't have the box, which eventually you won't have the box, I made these for you, is you'll draw your own box. You don't need the circles, you really just need the box. Okay, so you'll start by drawing the box. These zeros right here, or these open circles, are just to show you where you're going to put your terms. So when we do this, we're going to take our terms that come from our parentheses, and we're going to write them in here. So I'm going to write my 3x, and it really doesn't matter where I write the 3x plus 4. I can write them up here at the top, 3x plus 4, or I could write it on the side, 3x plus 4. It doesn't make a difference. It's still going to result in the same product. So I'm going to write it on the side here, if I get my pen right. So I'm going to put the 3x in the first circle. I'm going to put 4 here. Again, the circles aren't necessary. You don't have to draw them. Just put them next to the locations on your 4-square box. Now I'm going to put x plus 2 up at the top. So now I've got it set up right. So I've got a box, and each of these rows and columns have their own term there. And all I'm going to do is multiply the two terms that are on the side of a box. So I'm going to take 3x times x. and I'm going to get 3x squared. Pretty simple. I'm going to multiply this by this. Now I'm going to draw this over, so I'm going to take 3x, and I'm going to multiply it by 2 this time. So they share this box, right? 3x plus 2 is 6x. So you can kind of see the pattern here. It's not too complicated. 4 times x is going to fill in this box here, so 4x. And then finally, 4 times 2 should fill in this box, which is 8. Now you'll notice a little similarity. If I can get my screen to scroll here for you. And it doesn't seem to, there we go. You can see the similarity. We got up here 4 terms when we did this, right? When we multiplied those binomials, 1, 2, 3, 4 new terms after our multiplication. And if you look at our box method, again, we have 4 terms, 3x squared, 6x, 4x, and 8. So it's just a different way to do the distributive property. Instead of drawing the lines, we're putting the products inside of this box. Again, it seems kind of tedious now, but when we get to the factoring, it actually will benefit us a little bit because it plays into how we do the factoring portion of it. So I really do like the box method here, while it is a hair more work. Now all we're going to do is combine any like terms. And you can see our like terms are going to be these two here, our 2 linear terms, right? 4x and 6x. There's no other x squareds. There's no other constants. So let's write out our final product here. So we should get 3x squared plus 10x, if we combine those, plus 8. All right, so that's our final. Again, it is a quadratic trinomial that we get when we're done. Let's do another one of the boxes, just because it's new to you, so we'll spend a little more time with it. Let me pick a darker pen here. Again, let's line them up. Again, it doesn't matter which one you write on either spot here. So I'm going to write 2x and a negative 3. And then I'm going to write the 3x plus 6 at the top. Don't worry about that plus sign. We've got our negative right there. Remember how I spoke about these terms is that you take the negative with the term that it's in front of, or whatever the sign is it's in front of it, you take it with it. So I'm going to write the negative 3 there. Don't worry about putting it in between. I'm not too worried about that. This came with the image. So again, let's go back to our process here. 2x and 3x are going to fill this box. So 2 times 3 is 6, and x times x is x squared. And again, moving over to the next box, 2x times 6, that should fill in here. So I'm going to get 12x. And then again, let's fill in this last spot, negative 3, or last 2 spots. Negative 3 times 3x is going to give me negative 9x. And the last spot is negative 3 times 6, which is going to give me negative 18. There's my 4 terms. And when you do this, you should also kind of see a pattern develop out of the box and or the distributive property that there's always going to be like terms of the linear terms that are in there, the linear monomials. There's always going to be like terms like that. There'll never be an x squared. There'll never be a constant that comes out of it. It'll always just be the linear terms that we're going to add together. And that'll be the same for FOIL. It'll be the same for the distributive property. It's just kind of the pattern that comes from multiplying binomials, right? That's the pattern. You can make that assumption. So let's finish this off. It's going to be 6x squared. Combine those, so a negative 9 and a positive 12 should give me a positive 3x when I'm all done with that, and a negative 18. And again, we get another quadratic trinomial, 1, 2, 3. So that's the box method. Now the FOIL I'm going to go through quickly because you've seen these before. So FOIL then is first, inner, outer, last. That's what it stands for. First, inner, outer, last. Notice it's not very mathematical. It's really just an acronym. And I don't mind the use of acronyms, but in this case, I don't think it really shows you the process. Again, it's just the distributive property minus the arrows. It just reminds you how to multiply these. So the first meaning 3x times 2x or 6x squared is the multiplication of those. Inner, so let me change the color here. Inner then would be the inner 2, so these two. So negative 5 times a 2x or negative 10x. I'll try to change the color again for the next one. The outer, which is going to be the first term and the last term, the outer 2 terms. And again, see how this is kind of antiquated. It doesn't give you a really good process. It does give you an acronym, but I don't like it because it jumps around. It's not too systematic for me. But anyway, back to it. 3x times 7 is going to give me a 21x. I got to have a plus here, right? It's positive. 21, and there's an x. And then the last are the last 2 terms. I don't know if I got black up here, so I do have another color. The last 2 terms is the 5 and the 7, which is going to give me negative 35. So, and then we would combine our like terms in the middle. Again, we get two linear terms, still consistent with what we've seen with the other ones. So we're going to have to combine these two here. And then that will be our final quadratic when we're done. So we should end up with a 6x squared. Negative 10x plus 21x should give me a positive 11x, correct? And minus 35. All right, so that's the notes. That's the FOIL. There is an example down here. They give you a couple boxes. Let me just talk you through it, and then I'm going to let you work for the rest of the hour. This one says, find the surface area of the shaded regions. You'll notice that you get a box in the center, right? And we need the area of that box. But we've got to subtract it because we just want to take this shaded region. So the shaded region is all of this around that box. So we're going to take and multiply these two. So x plus 2 times x, and that's going to give us the area of that inside box, okay? Area of the little box inside. And then we're going to take that, whatever that area is, and we're going to take the area of the larger box. I'll make a bigger square here. And we're going to subtract the area of the little box. So in the area of the larger box, I'll do it in blue. I guess I am doing this problem. Minus, I'm not going to multiply it out. I'm just going to set you up for it. The larger box area then, I'm going to make a big box here, is going to be equal to 2x, because area is side times side, right? So 2x plus 5 times, and I'm going to have to erase it because I can't see it, 3x plus 1. So you'll see this problem comes up to is that we get a binomial multiplication for the large box. We're going to get a monomial multiplication, what we did yesterday, from the small box. And so whatever you get from this and this, you're going to subtract them. And so that goes back into yesterday's because we did do subtraction from that also. So when you subtract, make sure you distribute that negative to all the terms in that area of the smaller box, right? Make sure you switch all those signs. So that kind of sets you up in that problem. So you will have one of those in the book. I just want to make sure I talked about that for a second. Again, if you have any trouble with any of the notes, these will be available on the Google community page. I'll post them there. I will also post these notes onto the Weebly page under the Unit 5 tab. Right? It'll be down at the bottom. It'll say video notes. It won't say video notes support. That's the YouTube playlist stuff. Then if you have any questions, make sure that you post them to the community. I will help you. Or other people will help you and answer your questions, okay? But that's it for today. The bookwork's at the bottom. I think we can go down and find it. Here you go. And 469, it looks like you got a couple different sections to do. But it is just the odds, so you do have the answers. You should be able to check your work. And I will see you tomorrow, guys.